Hi there, future PEs. This is Wasim Asgar. I'm a licensed professional electrical engineer in the US and Canada. I've authored several books on the topic of FE Electrical and PE Power, and I also run popular exam preparation programs for FE Electrical and PE Power. In this video, I'm going to do a summary of NFPA 70E, which is one of the codes and standards that you are expected to be tested on in the PE Power exam. NFPA 70E is an interesting standard. It is most commonly known as R-Flash standard. R-Flash has been gaining a lot of attention over the last several years. And the main reason behind that is that our understanding of R-Flash is actually very recent. It was back in 1970s when Dr. Ralph Lee came up with a set of equations, empirical equations and formulas that sort of quantified arc flash as one of the safety issues. The scope of NFPA 70 is actually much broader than just simply arc flash. It is focused on safety-related practices for electrical professionals and personnel who are interacting with electricity. It talks about different types of strategies and rules and requirements that can help improve the safety of the electrical personnel. There's emphasis on PPE, there are few calculations as well. But the aspect of NFPA 70E, which intrigues most of the students, are the bunch of calculations in NXT IEEE 1584, which technically speaking is not even part of NFPA 70E. But as electrical engineers, we love the idea of being given equations and the formulas and numerical values to sort of play with them and get the answers. In this video, I'm going to be doing a brief overview, so I hope that you're going to enjoy it. If you're new to this channel, then please consider subscribing. On a weekly basis, I'm creating content for FE Electrical and PE Power, as well as Power Systems Engineering in general. If you have any thoughts and suggestions for future videos, then please share them in the comment section of this video. Thank you. So let us start with a strategic overview of NFPA 70E. Last week, we dealt with NEC, right? And NEC by far has the lion's share. If you want to look into the NCSP Power Sample Exam, you're going to see that about 80% of the questions that they have in the sample exam are from NEC. And as I mentioned in my summary last week, it is consistent with how the power systems engineers use NEC. Unless you're working in the high voltage, medium voltage, maybe in transmission and distribution, most of your time is always going to be spent on in NEC. Okay. The next closest thing to NEC and the standard that is sort of taken, it has taken off a lot, and it is getting a lot of attention, frequent updates, and a lot of work being done by NFPA is 70E. And loosely speaking, NFPA 70E is called as the arc flash standard. Although the title of NFPA 70E sort of and the scope encompasses much more than just arc flash. Okay, just like NEC, it is also developed by NFPA. And compared to NEC, in terms of its overall weightage, we are looking at 100 pages roughly for NFPA 70E compared to 800 plus pages for NEC. Okay, so 1/8 of NEC. It is revised every 3 years. At the time of today's session, June 2024, we are going to be using 2018 edition for PE Power exam. Every other year, roughly, they revisit this and revise it. Although it has not been revised for the PE Power exam for a long time, the latest edition that we have currently for NFPA 70E is 2024. Okay, so I expect that there's going to be an update. Whenever an update happens, NFPA actually is very proactive in communicating what the changes are. In fact, they have some publications that can tell you exactly what the changes are. 99% of the code remains the same. They only make minor modifications, right? So by the time you are taking your PE Power exam, if 2018 is not in use, chances are that there are going to be some very minor changes. And on my end, I'm always updating my content, so I will try and keep up the speed. Okay. The layout is very important. This is how we started our discussion of NEC. It is identical to NEC. It's written by the same body, NFPA. Okay. Chapters and articles. I strongly recommend always to all of my students to actually go through Article 100, which is definitions. for all the NFPA standards. In fact, even for NESC, which is written by IEEE ANSI. The most important chapter, in my opinion, is chapter number 1, safety-related work practices. So since this is only 100 pages, I think within 2 hours, you can read the entire NFPA 70E cover to cover, okay? And if you want to pay special attention, let's say a week before the final exam, then spending a little bit extra time and effort in chapter number 1 will probably be a high yielding activity. Definitely read chapter number 2, safety related maintenance requirements. Give it a read. Safety related requirements for special equipment as well. That is also worth your time. Okay. Then we have a list of important tables, sections, articles, code rules. Within the on-demand course, you I think it's upfront in the code and standard section. I have a downloadable spreadsheet which contains an exhaustive list of all the code references that I have used. Okay, so please make sure you download that. But if I sort of give you a high-level summary of NFPA 70E, 100 I already mentioned. So pay special attention to terminology such as arc flash hazard, shock hazard, qualified person, de-energized, energized equipment, and so on. Give this a read, 105 applications of safety-related work practices. Then wherever I'm recommending or highlighting some of the key rules, this is where there are interesting tables that we use in practice as well, or they may be related to some of the calculations that you may have to do. So these are general requirements for electrical safety. On NFPA 70E, I think the 2018 edition, the one that we're using, the cover of that NFPA 70E edition actually has the pyramid, which is a hierarchy of risk control methods. And one of the things I like to tell my students is that PPE, when you look at it, is not the first line of defense. It is the final line of defense. Okay, it is the last line of defense. So you should not be counting on PPE as the only thing that is going to be protecting you, because that is ultimately the final line of defense. And by the time the hazard is, come so close to you, you are actually in a very dangerous situation. Okay, so make use of substitution, elimination, engineering design, procedures, and awareness in order to mitigate the risk. What's so special about test instruments, as we discussed? Because whenever you are testing majority of the time on live equipment. So you're not in a de-energized state. So you have to be even more careful. 120 deals with electrically safe conditions, establishing electrically safe working condition. Lockout, tagout, we discussed that in the program. You have some interesting code rules 120.5. I have a star over here, table 130.4DA, shock protection approach boundaries for AC systems. Within NFPA 70E, this is one of the most frequented tables, right? And a list of all these tables can be found in that spreadsheet that I mentioned. 130 is work involving electrical hazards. So you have the energized work, shock risk assessment. And the most interesting thing when it comes to calculations within NFPA 70E is that question whether I can use the arc flash risk assessment, arc flash PPE categories method, or do I have to go through those ugly equations using the incident energy method? Okay, and we discussed this in a lot of detail in the program as to which method can be used. And the simple answer is that if the scenario that is given to you perfectly fits the options that are provided in the table, right? Arc flash PPE category method for AC equipment. If it fits perfectly, then go ahead and use it. You don't have to do any calculations. But the issue is that even when we are using the category method, notes in the table that have specific requirements are generally ignored. This is in practice, right? Sometimes you have assumed values, not the actual calculated values, right? And that goes for even the protective device clearing times, right? So if you want a rough ballpark, then this is not a bad place to start. If you have accurate details that are matching perfectly, then go for it. But otherwise, you would have to perform the incident energy calculations, a few of those that I revised and reviewed earlier in the session. Okay. And that can be because of multiple reasons. And when it comes to the incident energy method, NFP 70 NXD contains those steps. And in fact, they've gone a step further and included some calculations, sample calculations. So I strongly recommend that you guys actually make use of that. Okay. Where they have sample calculations, just go through them, follow those sample calculations, and that would be helpful.